Thanks so much for everyone that could join us in this meeting. And the mainly objective here is just to show you guys and other people that can watch this in later moments, because now we are recording it. And okay, we did a small research and here in White Prompt, and we are increasing our knowledge and trying to figure out how can we help our clients to achieve more and using the AWS resources to be more data driven and help them to discover and having more insights and real-time delivering data with using the best of data lakehouse architecture. And here we have our agenda with some points that we are covering in this meeting. Okay, the principal one here, we are walk through the past, for example, and talking about some pain points from the previous and not so old, but in many of other companies in the market still using data warehousing solutions, because it's not so trivial to migrate some architecture to the newest one created in this data culture, and go to the data lake perspectives, go and see how the evolution of this architecture is going on in the markets, and how the AWS has some approach and which services good or not to use, and try to create totally integrated solutions using AWS services. Showing you guys our proposed solution and what we did and which services we are using, go to the demo and showing exactly hands-on and things happening in real time here, creating services and generating data in real time and consuming it in a fast way. Okay, let's go to the happy party. And here, as we can see here, and the data warehouse in the past helped us a lot, because in that moment it was only the principal way to centralize and getting some business insight and KPIs from our business data, and have a centralized data doing ETL itself and getting data, for example, from many relational databases in the past, for example, Oracle, SQL Server, and creating some data marts and other ODS table representations inside some data warehouse solutions. Okay, but this is not so good for the time being now, because the technologies and data needs increase a lot, and from one day to another day and also months, the data requirements is changing and the data evolution is so high. Many points of data are created, for example, from sensors, IoT devices, and many things that data warehouse is not, for now, the best solution to centralize our data and achieving some insights. Okay, but here we can point some data, some details that couldn't be so good for still having data warehouse. For example, high costs for of storing data, because trivial storage, for example, the old SATA, for example, disks are so expensive. We don't have too much speed to read data and write data, and even the cost is so high, mainly now in this pandemic where we are facing the world. The prices of everything is almost are reaching the Mars. Okay, the inability to handle many kinds of data, for example, audio, video, and even structured data, retrieving data from some APIs, or, for example, NoSQL database with many, for how can I say this, nested data types, for example, arrays, structure of data. This is not supported by trivial and native data warehouse solutions. Okay, and the same is here for machine learning purposes that we are talking so much and every day almost in many projects. Data warehouse is not a good fit to have a native way to consume data and help us to have some insights with machine learning models. And that in the data lake perspective, the technology itself helps us so much with comparison that data warehouse. We have possible ways to deal with different kinds of data, structured, semi-structured, and unstructured data, receiving from many sources, sensors and websites, doing some scraping, crawling from different sources. Dealing with nested data type and data lake is better than with data warehouse. We can try and using many different approaches, okay? But we still have some other points that we are working with data. We're talking, okay, how can we deal with these different needs, and how will be the next level and the next approach that the market and the research you're creating for and help us to deliver the best for our clients. And some other pain points here that I just put the main ones that some other clients are figuring out and asking us to help them to solve some issues. Okay, and one of the best point here, this is our pain point, but the best one and that is facing some details that we need to increase is poor data quality. And because, for example, when we are dealing with machine learning models, we must have the best data as we want, okay? Because using bad data to train models, it will give us the bad or the worst insight, and you won't help us to have some business decisions. And here, and how in this architecture evolution, this is the best way to show you guys how the evolution looks like, for example. And the first one here is the data warehouse. We just have the centralized relational databases, and we have some ETL process using many tools from us, for example, from SQL Server and Microsoft. It's possible to use SQL Server integration services, Oracle, ODI, Informatica, and so on, many other sources to starting retrieving data from structured data, many relational data, and creating the data warehouse centralized solution and just consuming with native reports and business intelligence solutions. But when you go to the data lake, the picture we are mostly changed. Now we are having more support for even structure is native, but semi-structure and with NoSQL databases, audio files, and even XML files is possible to do with this. And web scraping solutions are another possible data sources for us here that we can deal with this and ingest those data inside one data lake central repository. One big difference here, we don't rely on storage, physical storage that is maintained by, for example, IT inside our company or inside the client's company. We are relying in cloud storage, for example, in AWS, mainly using this S3. We have many other options for file server and distributed file services in AWS, but the common use is these S3 buckets. Not only for the easiest way to use, but for the price too. Is the best for the environment. Okay, and here we have a couple of other services that you'll be easier to integrate, but when you come to data warehouses, we still have other issues. We are plugging in the data warehouse inside our company and retrieve some data and merging or doing some joint perspectives just to show you and to having a way to be data consumed by data scientists or even for machine learning, but this is not so good approach. Okay, going to the data lake house. Now we are, for example, in that moment, we're having a centralized layer, for example, in data, where we can use some native formats, for example, using ARC format files or even Parquet. But as in data lake, they don't provide for us, for example, ACID, as transactional database does. And the best approach to using the stored format in data lake house perspective is to use, for example, the new generation of integrated file formats. And here I can point 3 of the mainly used, Apache Hudi. This was created previously by Uber, and sometime when they worked on this, they improved this a lot and open to the community to be supported by Apache. And for example, AWS are using it as a native data format, but we can have, for example, Delta Lake that was first created and maintained by Databricks, but now they have an open source version, and even another is called Apache Iceberg. This is very cool, very cool too. Okay, and here we can walk through and see the mainly 5 layers of the data lakehouse approach inside AWS. Here, the first layer we can use, for example, many of the services that AWS has in their lack of services. Ingestion layer, for example, using App-Flow, data migration services that we can ingest data inside our storage layer using relational databases or even NoSQL databases using CDC change data capture services. And data sync, that it's possible, for example, retrieving data from flat files, shared folders, or even connecting to external sources as, for example, Salesforce. And here is the Kinesis family, let's say. We can retrieve data from near real-time or real-time solutions, extracting data from web services, from sensors as IoT, or retrieving data from social media, for example. There's many other options that we can start doing things. And in the storage layer, we can integrate, for example, Redshift Spectrum, creating data directly from the native and integrated solutions, as I mentioned in last slide, and Apache Hudi, for example, or even Delta Lake. And inside of it, we have a next generation catalog layer that is provided by the AWS Glue services, okay, that they have not only for processing, because the AWS Glue has many sub-services, let's say. The main one is used for Spark as a services that we don't care with infrastructure, but we can use the native catalog that has integration with almost every data analytics services. And in the processing layer, it's possible to do transformations based ETL inside the Redshift Spectrum tool, querying directly the S3 data. And in EMR big data is just, as we commonly say for my colleagues here, if you have real big data, more than 1 terabyte of data or almost 500 gigabytes, okay, don't use Glue, because it will be a very good, a very big deal for you dealing with big data with Glue services, because this costs a lot. And one good strategy to use EMR solutions and just to rely on spot instances, for example. The well-defined strategies with spot instance could help you to save a lot of money and deliver the same as using, for example, on-demand resources. And in the same layer here for processing, we have the new real-time ETL, as I mentioned in Kinesis, but we can use even the Glue processing services and even the EMR. For consuming layer, as we are using now in this in the next slides here, we can use the Athena service that is a very good query engine that is powered by Presto inside behind the hoods of Athena. They are using the Presto solutions, a query engine, and even Redshift Spectrum can be used by this inclusive layer. We can create some dashboards, for example, using QuickSight, or if you want to create another structure for presentation layer, we can use, for example, container services, deploying other solutions as Superset or Metabase. This is a very good solution of open source ecosystem that could help you in this consuming layer. And even SageMaker can help us to achieve and training models and presenting some KPIs. Next one here will be our solution. And here is just a small drawing that represents what the principal objective here of our call is to demonstrate in real time how can we generate data using a simple, not so complex data generator written using Python language, okay? Then we send this data as a JSON format, for example, to this Kinesis data stream that will be a data receiver, and then the Kinesis data stream, you send this stream of data to firehose, where the firehose, you write those data directly inside our S3 bucket. even with that, we're still using the data catalog to have our unified and auto identifiable way to infer our data schema. For example, here, we don't need to go directly inside Amazon Athena and write the command create table as and define the whole list of columns. The Apache Glue data catalog has this functionality to auto infer and discover, for example, the field names, the data types, and even more. Have you guys some doubts? And here just a list of our proposed solution services and the purpose of each one here, just a small explanation. I forgot to tell one detail here, and let me go back. Every service here, and we are creating in an automated way, let's say, using Terraform. Our infrastructure was created by code, let's say. We are, for example, in almost every client that we are supporting solutions like this, we must thinking how can we reproduce it, not only for creating production environments, but okay, I start in development environment, quality assurance, development, and go there to the production. And how can we ensure that every environment will be the same? And this, what comes the Terraform, okay? And here I visit my presentation and go to the AWS console. And here we are in our account. One very good thing here, not only for AWS, but other cloud providers, they have this integrated cloud shell here. In the AWS, you just click on this icon here, cloud shell. I have this open for me. This is my home directory inside my cloud shell. I just go 2 steps before here. This is my GitHub project. Okay, this GitHub project is this link here. I copy and paste after this link here in our chat. This is a public project that the same code here we are using to execute everything here. And in this structure here, we have our data producer. Inside the infrastructure here, we have our code used to create the infrastructure. And here we have the Terraform binary that I previously had created this environment, but I will create it again just to have it and show you how this works. Let me execute some comments here to show you how it will be created. This is just to show you, okay, we have the good version of Terraform, and it's a standalone version. Okay. Let me do one thing before here. I delete everything before, because we have the states here. I just start from beginning, as we don't have nothing before, just cloning from the scratch. Okay. And first, just downloading the standalone version of Terraform and Terraform init, just to initialize the context and the providers of Terraform that we are using here, AWS providers. Okay, this message here showed us that everything was successful initialized. And here, let's create our Terraform plan and see which service will be created inside our account. And it's possible to look. Let me go up. Okay. Here we have the log groups of CloudWatch that will be one way to centralize things that could be good or wrong inside our Kubernetes delivery streams. Okay, here. Here's the service related to Glue database that we use to create data inside the AWS Athena. The table that we generate as we define the schemas before in our design of products, where this data will be stored, and we can see here the path. Okay, the file format that the final deliverable service you create for us in Parquet format. And this way here we are done using the unified files, for example, as that Delta Lake, the columns and data types that of this table. And here we have the IAM hole and the policy that will be needed to allow us to query data and create other services. Policies, delivery stream here. Everything here is okay. And now I just execute the Terraform apply with another parameter that contains every definition of service here. That is our stack plan. We are not using too much services, then this creation is so fast. It's faster than going to the screens, click, define names, and correlating services, correlating policies. Using Terraform, having the infrastructure as code is the best as possible. Okay, the outputs show for us here the ARN from the stream and the stream name here. I just go through the screens of services before generating some data, just to show the services created. And here we have one data stream that was created now. We just have one shard of Kinesis string, but we can have many shards as possible. This is related to our data needs and with the speed we want to deliver and receiving data inside this string. There are many configurations that we can apply and have here the stream metric is monitoring that is showing us data receiving in this stream. And here is our delivery stream. This is commonly known as fire hose. This service here will be responsible to write our data as a Parquet format inside our S3 bucket. Okay, we have other statistics here. And the last service here, I go to the AWS Glue. Just to show you the definitions of our database that was created and the table. Okay. We don't have data yet inside the S3 bucket, but we could have the definitions of database here and even the table. We have some parameters here, the definition, the schema definition. Okay. But if you go to the AWS Athena and try, for example, querying some data, you'll see some errors. I try it just to show you how it looks like querying something that doesn't have data inside. And here we can look the table definition that was retrieved from the AWS Glue. One simple way to query data here, just clicking these 3 dots and generate an preview table. No hazards because we don't have data generated inside our S3 bucket. And let's go back here to AWS Cloud Shop. This is a simple script that I am using now to generate data. Inside our requirements, just to show you guys, we have just one requirement, true. the Boto, that's library, native library for Python, the SDK, and a faker. This faker is widely used for generating tests, and create some Python tests. We can create as many data as needed. Let me create my virtual environment here. And let's activate and install our requirements. Okay, everything is done. This Python script here has one parameter that's called amount. This amount here means how many records I want to generate and deliver it to Kinesis stream. For the first moment, I will just generated 100. Just for tests, generated this 100. Go to the console of Kinesis, take a look at the statistics, go to Athena and query this data.
And Jonathan, what this script is simulating will be the real data produced by an application or an integration, right?
Right, yes. Good, Fabricio. This data is simulating, as Fabricio said, for example, one IoT device generating temperature and humidity and even location coordinations location and sending to Kinesis. And as this data arrives inside Kinesis, we can arrange how this data will be transformed, enhanced, or delivered directly to the S3 buckets. Okay, this is a simple schema definition. Let me go back here and see Kinesis here. Feel free, guys, if you want to say something, asking some questions, no worries. We just change to 1 hour. Yes, we have some points of statistics here. Okay, here. And the latence is milliseconds. This is good. Let's open the delivery stream here. Okay. Let's go back to S3 and see if the data arrives there.
Another quick question, Jonathan. So this delivery stream that you create on Kinesis, what does it do when you send data to Kinesis?
Okay, the delivery string is responsible to convert our JSON that is coming from my ingestion or my data generation, my data generation script. And it's possible to do some transformations in real time, for example, using Lambda scripts, Lambda service with some Python, other language scripts. But for time being, we are not doing some transformation. We are just retrieving as is coming and writing it as a Parquet file directly inside the S3 buckets.
Thanks a lot.
It takes some moments here. The Kinesis has received records, but inside the no, that is not. Where is it? Sorry, let me I forgot the name. This is the bucket. I opened the wrong one. Sorry. And here I have the name of this table, the year of data that was generated, the month is March, the day that's today. And here we have the data that was generated. You to see the time of Brazil here and the Parquet file that was generated. Okay, and if I go back to Athena and execute it, let's see. Is our generated records from our Python script. If you have more shards, maybe this could be as fast as possible. But just for this purpose here, one shard is perfect. We don't need more than just a couple of records. And let's try generating a little bit more records. And yes, let's put 2 zeros more.
Hey, Jonathan, I might have missed
Hello?
I might have missed a step here, but I'm curious how those schemas were generated.
The schemas of data, this table?
Yeah. So in Athena, yeah, exactly. Where did that happen?
Okay, the table. Let me go back first of data generation. Go to the blue. The schema was created. Let me go to a different thing here.
Okay. Was that something that happened in the infrastructure as code to create this?
Yes. I will show you here the Terraform.
Okay.
And here we have the definition of this table. Okay. And here.
Oh, I see.
We have the schema definitions.
Schema.
The columns names and their types.
Okay.
But as you ask, let me show another possible way to have a centralized schema registry, for example. Let me quit here, and then I go. I won't finish because we don't have this created yet here, but let me just show. In AWS Glue, as I said before, we have many possible ways to work with. We have these tables that we are working now, but we can use crawlers. Right. Crawlers is the main objective is, for example, scanning some buckets, some S3 buckets, and discovering the data, the table structures, and automatically creating and feeding databases with tables and their schema definitions.
Right.
But we can still have another possible way and have a complete integration. Oh, I have one schema register here. Complete integration with Kinesis and other services, for example. The schema definition, this was one of my previous proof of concepts using this service. I have one schema here for customer, for example. As I don't remember exactly the definition. Let's see. We have a version 1. This is a simple schema, okay? Then we have here the UID, event data, status. Oh, this is the schema of this proof of concept, the Kinesis, but I just created with a different name. Okay, no problem. And let's try one thing here in real time. I create a new table and pointing to this same location. Manually, okay. Or no, let's add from an existing schema, okay. And customer, I put this inside my Kinesis. And here my source is going from S3, but I can have integration directly from Kinesis, not feeding data with S3. And I just select here and specify in my account, the path will be this one here. Okay. And I choose my schema registry that I show you guys and my customer definition. And I just have one version.
Mhm.
And here is the same definition as the Terraform, the same fields, but in a JSON format.
Okay, that makes sense. Yeah, I've tried something similar to this before, where I did the crawlers.
Yeah.
I oftentimes would have to go in and fix the data types that get picked up. You know, sometimes you have a number and it thinks it's a string. I don't know if you've run into that before, but I guess it really depends on what the data coming in is and the cleanliness of that data. But we've had things like we'll drop a CSV type file into S3, and then the table that gets generated off of it is all strings, or it just doesn't figure out what the data types should be properly. So I was curious how it was picking that up correctly, but this makes sense.
Yeah, cool. And here it was automatically classified as error, but it'll be possible to change or no, but let's go and update here and crawl. Let's see the tables. Oh, we have the customer here in preview. Yeah. I tested it one time before, but I don't remember. Yeah, the third infos here is not exactly as expected. Let me just try one thing here. Is out of the scope, but it's good to have and show you different things in real time. Edit table. Parquet.
Okay, so it picked up the wrong classification there, you're saying?
Yeah. Let's try again. I don't know if it works. No. Yes, the classification is completely different here.
Oh, input.
Here, let me go back and.
Yeah. I think I'm not sure about this, Eric, but I think the crawlers use some machine learning behind the hood to decide what is the proper data type of a field. And sometimes it does a good job, sometimes it does not.
Yeah.
So some manual tweaking is always good.
Yeah, and yes. I like that this stores versions of every single schema as well. So you can go in after you've run a crawler and see that what happened is what you expected to happen. For example, you change the data type or the data source to add new information. You can run it again and just kind of view what changed over time, which is nice.
Yeah, but now I changed it here to be as the parquet was created, the original from the Terraform was created.
Mm-hmm.
And let me update here. No, still doesn't work. Okay.
Yeah, it's okay. We can keep moving. I was just yeah, unless you wanna.
I'll find how to do this, but
yeah.
And let's generate a little bit more data.
Are we going to cover QuickSight in this as well?
Yes.
Okay, awesome.
We can use QuickSight or other open source, for example, Apache Superset or even Metabase, and to query and connecting directly to the Athena.
Yeah, we're using Tableau. I'd love to see. I mean, just any.
Yes.
Yeah,
Tableau is a very good tool. I like it.
Yeah.
But in terms of open source, my recommendation is Superset first and Tableau in second. And go here. Generating. Yes, I put a 1 0 more. Okay. 2 zeros. one interesting thing here about this script, every record that was printed in this screen was already delivered to Kinesis. For example, if I stop it here, we had some problem, okay, because it was interrupted suddenly. But if shown in our screen, it was delivered. I exaggerated in data generation. Let's put 2 zeros instead of 1. And go to Kinesis here, and let's see the first this one. You should see the increasing metrics for new data coming. Yeah, the data is coming. One more here. Yes, the big peak here goes to the moon. And let's see inside the bucket. Yes, we have another Parquet file that was created. And let's see the records here, the count. Yes, a little bit more. Yes. Everything looks good as expected in data generation. And do you guys have more questions?
I wrote one question in the chat because I didn't want to interrupt you, Jonathan. And I was curious about, you knew that behind QuickSight's hood, there is Presto. How about the data catalog on Apache Glue? Do you know what is powering that, or what is behind the...
You mean Apache, you mean Athena?
Exactly. I mean, not exactly Athena, but in order to query Athena, we need the data catalog that you produce with a crawler or manually in Glue. Is that an Apache Hive data catalog, or is something different?
Okay. Behind the hood of Athena, they have the Presto service, the Presto query engine.
That's right. Sorry,
and behind the hood of Glue for automatically inference of schemas. I imagine, okay, I'm not sure. They could have like some queries or some intelligence to gather the Hive metastore catalog. Because if you don't have, for example, your AWS Glue data catalog, you can still having one Hive metastore and pointing the Hive metastore connection to external MySQL database and storing every table definition inside this MySQL. But I don't know exactly the service behind these crawlers of the AWS Glue, but could be some sort of Hive strategies with internal databases and controlling by the AWS. Here the chat. Okay, with the environment created. Let's go to the final part here. And to don't spend more money, and okay, if I don't want any more services in my infrastructure, just execute the Terraform, just try service command. Every time that you run this command, the Terraform will verify exactly if the same services that you previously has created, they existing yet inside your infrastructure. You have this resume of services, and they show you that everything will be destroyed. Until you confirm this, nothing happens. And if you wrote yes, the only thing that won't be destroyed here will be the S3 bucket, because we have data inside. This is the only services here. The S3 bucket is not empty. And if you want to delete everything, just go to the S3 bucket, delete everything that was created, and delete the bucket. But if you go here and see, you don't have more the table, the database, Kinesis, no more, delivery string here. We don't have more services inside our account.
Very good.
I think for time being, this is what we expected to show you guys. And feel free to ask more questions. I'm here to help you as much as possible.
I have one question. I know, Jonathan, you are doing follow-up research to this, like the second part, the third part. I understand it is a 4-part series. What's coming
Exactly.
next? What will you be exploring next?
Okay, this is the first one, as Fabricio said, part of 4 blog posts that we are creating and exploring more alternatives of services. The second one, I told you guys, will be, for example, extracting and retrieving some New York taxis data, and it could be real time or near real time, but we're still working for this moment, because we try here, for example, a real time using Kinesis streams, and the second one will be a batch processing. You will be retrieving data as a CSV files and doing some sort of transformations and enhancement of data using the EMR services that behind the hoods there, you start using Apache Spark to process data. And our S3 bucket, our data lake, you'll be responsible to receive the generated new data using this new format that I mentioned, the Delta Lake format. That will be easier to us to upsert news data that is coming from, for example, if I receive in a customer, for example, Fabricio customer history for one particular scenario, but Fabricio has one record inside. But Fabricio has your cell phone number changed. But Fabricio ID inside this table is still the same. When this new data arrives inside my data lake, the Delta Lake, you help us to have this ACID compliance as relational database does, and you update only the changed record, the changed value of some columns. But in this example, the phone number. Or if I have some, for example, deleted records from my original database that is coming from CDC using data migration services, for example, the data will be deleted from your data lake, because the Delta Lake works in a way to reflect exactly as your source of data. You're telling you how your data is in your source, deleting, updating, inserting new data. Delta Lake, Apache Wood, and even Iceberg. You help us a lot in these terms of updating data, and has almost a relational database inside a Lakehouse infrastructure. and is it.
Cool, thanks a lot. So in terms of the Lakehouse, what we've seen is using an event-driven technology to feed a data lake, and in the next issues of this series that you're doing, we will explore the other parts of the data lake, the other components.
Exactly. Yeah. Let me share just again my screen, just to show the next services that you'll be using, just to have a perspective. Are you seeing my screen?
Yes.
Okay. As I mentioned here, we can use, for example, data migration services to receiving CDC, change data capture from relational database, that is this service here, and the ingestion layer, or as we did now, using Kinesis to ingest real-time data that is coming from other applications. And in our storage layer, we're still using S3, but we can choose and use Redshift Spectrum. For catalog, we will try this integration that I did here, but doesn't work well with schema registry. I will increment the scripts to have a support, to have a centralized way to have the schema evolution with schema registries. And our processing layer, you'll be done using EMR cluster with this approach to using spot instances to save money and doing the same thing, but with almost or more than 70% of discounts. And in another blog post, we will cover some presentation layers. For example, here we can use QuickSight, but I will approach using, for example, Apache Superset, a different tool that is not covering as a native AWS services, but is a very good service on open source alternatives.
Sweet.
Yes, guys, this is what was our plan, just to show you how we are increasing our service offering and data. And here in this Lakehouse approach, we had to show you some details and how it's possible to work with real-time data and near real-time data, different ways to ingest data inside one data lake. Yeah, I think is it. If you guys have more questions.
Nope.
Thanks for the explanation. I appreciate it.
Thank you.
Yeah, indeed. Very good.
Thank you, Daniel.
Cool. Well, if there are no more questions, we appreciate your participation, guys. And if it happens that you can think of another question after the call, feel free to send us an email, and we will be happy to jump. Oh, just one thing that I forgot, Jonathan. You presented the Lightning Talk, and it was great, but you didn't talk about your professional experience. I don't know if you want to share some about your background.
Yeah.
We saw your name on the first slide, and I didn't want to interrupt, but I was curious about that.
Yes. Okay. Now here in Whitefront, I'm working as a data architect, supporting some of our clients to design some architectural perspectives in terms of data ingestion, schema definitions, data quality, data monitoring, and stuff like this. And I working with data for more than 10 years. I started working as a database administrator, administering since small environment to large ones using SQL Server, and even some environments using Oracle, and Oracle with high availability solutions with Hack, and SQL Server 2 using high distributed SQL Server clusters for national and international projects. I live in Brazil here, but in the time when I worked, for example, for another companies supporting clients here in Brazil and in the US too. And before coming here to White Prompt, I was working as a data engineering specialist for a financial company here in Brazil, defining some data lake strategies and ingestion, and to have best and very good KPIs for this financial company.
Cool. Thanks a lot.
Thanks so much, guys, to joining us here in this call. This is very good for us.
Thanks a lot for joining, everyone.